Thank you, Julius. That was inspiring information provided regarding where we're at with data centers today and things that we can do to streamline our existing facilities. In my piece, I'm going to be looking at kind of where we're at, where we've come from as well, where we're going in the data center industry, and some new technologies that GKK Works has been looking at with various clientele in the industry. So I kind of outlined this from where did the heat get started? In the 1980s, when we were first seeing the advent of data center proliferation for office utilization in metropolitan areas, it was all about getting infrastructure close to the end user and doing that in a fashion wrapped around putting your equipment systems within the same building as your people to gain accessibility to information at the PC level. So essentially we were utilizing IT systems used to reject heat into central building systems. This then went into an increased demand distribution, going from token ring, which led to routing architecture, the advent of LAN networks. Closets began to take on more demand. Changes in the data centers required changes during low processing time. Original data center design concepts to protect mainframe CPUs were routed around the ability to start to look at advents like providing dual utility sources for systems that required to have more and more increased uptime and reliability within the data center architecture. Air delivery and heat rejection were two separate requirements. And that, because of the mainframe, was a device that both utilized air as well as water media for cooling at the chip level. So as we started to increase our densities, we started to realize that the closets were getting hot. So we needed to adapt and develop new technologies that will allow us to put in temporary solutions to give us ride-through in increasing these either tied to building systems or what were becoming independent data center cooling systems that transcended into dedicated rooms outside of the closet for exchange of data center architecture and developing through data center facilities at a commercial level, adopting a lot of the different design criteria that had developed out of the government and companies that were on the bleeding edge of those solutions. As we started to move further down the line, we started to realize that the heat's growing, that it's not getting any less, and how many people have seen this chart on infinitum since the 80s and 90s, dictating that this increased heat load continues to expand and grow every time the hardware manufacturers decide to put an additional layer of compute infrastructure onto a chip, and that's transcended from mainframe through DASB, through storage to server and server storage arrays and SAN networks, all the way to where we're at today, where we're seeing that the adding of this compute is not, while bringing the power down, is not limiting the heat load. So where's all of the innovation? As an industry, we have continued and still continue to look at innovation from a hardware perspective, innovation at the compute standpoint, the innovation at the data center level and the facilities to support it have not dramatically changed over the years that we've been building these facilities. We continue to take that load and spread it over a multitude of square feet as a means to mitigate and reduce heat at the server. So instead of trying to work within existing environment, we continue to react to the industry, and as new hardware systems are put into place, we develop new architecture and larger real estate to support that hardware initiative as that heat load continues to grow. Since the advent of the data center, we've been building around the same design concepts. Put it on a white space, throw cabling under it. Some innovation has been wrapped around taking raised floor out of the environment, ducting directly to the IT cabinets, creating more holistic return systems, but it's all wrapped around the same concept of having the heat come out one end of the box and cold air go in through another, and carrying it distances across the data center floor as a means to get that heat away from the chip and out of the room. So the question is, why is this green? Where are we getting any better benefit out of these designs when we're having to deforest and increase real estate and create larger facilities to support this data center infrastructure? And how does this help? The new ASHRAE guidelines have come out, as Julius detailed in his piece of the presentation quite adequately, and we're now resolving these issues by widening an envelope, by dictating that it's okay to operate the data center facility at a higher temperature, but are we decreasing the amount of space that we're utilizing to develop data center facilities based on these new requirements that are coming from ASHRAE? In looking at the percentages associated with heat rejection in the data center, this chart shows that the percentages of power and cooling are used by the data center primarily for cooling the systems. By getting that heat out of the data center, the rest of it is all pretty ancillary in terms of heat load and gain in the data center itself. The bigger issue, and the issue that continues to daunt the industry, is how fast can you get that heat out of the chip environment so that it will run optimally at the processing ranges dictated for any one particular business initiative. So we start to take a look at some of the innovation that's come out. 2004, someone came up with an idea to put data center together as a means to handle more load and throw additional cooling on top of the cabinet. The designs were augmented to handle loads greater than 10 kW. So 10 kW is, at the time, quite a hot load for a data center environment. A lot of companies weren't seeing anything many more than maybe 3 to 6 max within data centers in 2004. But that was a temporary band-aid, was a means by which to gain ability to handle more heat, but now that heat has started to increase. We're seeing data centers operating at anywhere from 10 to 25 kW at the rack level. And it's not becoming just concentrated in distinct areas, it's spreading. It continues to proliferate in the data center environment. We continue to try to satisfy this by distributing architecture in such a manner to handle it while gaining efficiency at the cabinet level. I still see that we're still inefficient at the data center level. Even with advents about developing free cooling as a means to get us better throughput on that efficiency. We're now driving geographic location based on where we're going to be able to get these free cooling initiatives put into place, and is that really helping us from a data center proliferation standpoint on a global level? So 2004, 2006, people started looking at modular concepts. Someone looks to develop a new module solution to handle more load in a smaller footprint. Sun comes out with a black box, 250 kW in a 20-foot box container. Awesome solution. Still has a hot aisle and a cold aisle in it. The next solution to come out, 2008, sees an increase, 600 kW in a 40-foot container. Still hot and cold aisles, though. And why is the design moving continuing to move along that direction of a hot and cold aisle? Because as an industry, we operate on a fear that water's not good to have in your data center environment. When, interestingly enough, the first data centers that were ever developed primarily ran the chips on water cooling technology. And why, as an industry, do we continue to shy away from ultimately what's a better media for handling heat than pure air? Modular designs, benefits to modular designs. The benefit is maybe speed to market. Maybe there's certainly not a decrease in overall cost. There is some, but the efficiencies and the costing models are still coming out to be about the same as traditional build. Although there is a decrease in time to market, there just isn't enough saturation to bring the price point down from that standpoint. It's allowing for some block loading. Commodity production will become more prevalent as the modular designs get better adaptability. Companies that are developing these as solutions on a global level for their businesses are going to be the front-end leaders in driving more of a commoditized solution in the data center environment to give us better opportunity to handle these heat loads. Flexible and repeatable designs are going to allow for solutions and innovations to replicate and be resolved at a faster rate, because we're now more in a manufactured process than we are in a pure design as you go methodology that we've been in. And I see there being a greater alignment to the IT stack. So as companies are looking to get refresh and or develop new design around IT infrastructure and hardware solutions that are coming to the market as a means to be more competitive to other businesses, that alignment to the stack is going to dictate an ability to deliver IT infrastructure to meet the business need at a faster and faster rate, which we are seeing today. So modular designs. A company called NextGen comes out with an infrastructure, no IT in it, but it's a pure example of that commoditization and developing infrastructure that will be replicated and will start the road on how to make it more efficient, how to make it more dense, how to make it more operationally effective for business as they get more adaptability in the marketplace. Here's another modular design by a company that's got a butterfly module that they put out. The module is got larger kW blocks associated with it, kind of a central plant concept, and a great ability to replicate end over end time after time while maintaining kW densities within that environment. But again, this is kind of spreading the load. We're at a certain point of being able to satisfy that kW requirement, but we continue to deforest and create these huge infrastructure that, for the most part, people are dictating has got more of a green theme to it. But if we're doing all this deforestation and taking all of this change in environment and putting it into new buildings, kind of failing to see where the innovation is or what we're doing in terms of being good citizens or have social mindset on IT to the environment. So the question is, we need to keep building like this, and why is that? So I guess this is kind of a pushback from my standpoint, looking at cooling solutions in the data center and questioning where the innovation is at. I think here's a guy with a good idea. Let's take a look at that rack and just get rid of it. So I kind of put this up there as a best show of innovation. The data center is a pig. Data centers consume too much and they support too little by design. Facilities are not going to get smaller unless densities increase. Hardware manufacturers cannot manufacture dense solutions without complex heat rejection solutions, i.e. this Cray Jaguar that's got a tremendous amount of infrastructure in it to reject the kW, but they do it very efficiently. They do it very economically at the high density level. So, kind of challenges that we see. Hardware manufacturers can only develop systems that are supported by today's data center infrastructure technology. So we're reactive. As hardware manufacturers come out with systems, we react and come up with solutions around existing data center environment, but all prefaced on the same types of innovation and technology that we've kind of honed in on over the years. Densities are increasing. That's not going to go away. Innovation on support structure, it's not keeping up. It's still too reactionary. This whole concept of looking at different media, looking at different solutions, is not adopted and utilized in a quick enough fashion, and we're not able to keep up to the more technological growth that's occurring globally around us. So kind of looking at what needs to change, I think this is an idea to look at. So I've been working with these guys in Chandler, Arizona, being that I moved out here about 2 years ago, and they have a pretty slick solution. It's a company called Elliptical Mobile Solutions, and they've developed both a DX and a water-cooled solution at the IT level that can handle anything from 1 to 40 kW, doesn't care about the outside environment. This particular unit is developed around a concept of closed-loop cooling, which was alluded to by Julius in his presentation as a means to develop more efficient concepts around rejecting heat at the point of the chip. So these guys kind of took a look at things more from a Tesla than an Edison standpoint from invention, and came up with a pretty slick solution around a DX model that initially was able to handle at 42U 16 kW of IT load redundantly with very little opportunity for failure within the DX solution. The system itself is completely transportable via a pallet jack. You can lift the whole thing up, move it around, and has a shock and vibe technology built into it, where you can put your entire IT infrastructure system into it, move it anywhere you want with no degradation to the IT equipment that's inside of it. So essentially you could stack everything that you want into it, ship it anywhere in the world, bring it to a site, roll it up to the line, plug it into water or air, and you're moving. You're on your way, and doesn't care whether you're at 1 kW or 40 kW. Infrastructure can be designed, and we've been working with these folks to design that infrastructure to be flexible enough to handle anything from 1 to 40 kW, one financial quarter ahead of any one particular design that a client has. The water systems for this particular units are totally separate from the IT. As indicated in these photos, the fan arrays that are in these boxes in total only produce 1 watt of power. So the efficiency and this is the water solution photo that I'm showing here, at a closed loop, there's no heat transfer outside of the box. All the heat transfer occurs at the coil, and they're efficient enough within the coil that they can do it at 1 watt of fan power, and essentially get to a point where they don't necessarily need the fans in the servers to operate. So these types of solutions, these types of systems answer to a lot of the efficiencies that are lacking currently in ability to be able to continue to drive PUE down at a traditional level without having to rebuild hardware manufacturers' server lines. So where a lot of companies are currently getting better PUE at below 1.1 in the industry, that's a culmination of being able to have access to your own line of server environment or building your own servers that will work within the rack environment the way that you want, and as far as to how you're setting your facility up. But for a majority of the industry, they don't have that luxury. So they're buying their hardware solutions directly from the best manufacturers in the industry, and looking for solutions to put them into a data center environment and do it in an efficient manner that allows them to drive that PUE further and further down.
Excuse me, Scott?
Yeah.
We are running a little short on time, and I'd like to get a question or two in.
Yeah, just one more slide.
Okay.
And I'm done. So looking at that densification issue that I was alluding to, and you know, 1.2 megawatt IT computing capacity, you can see fits in 3,500 square foot pretty nicely. You know, utilizing this kind of a solution as well. So with that, I will hand it back over to Kevin for questions.
Thank you very much, Scott. Thank you, Julius, too.